There is a specific category of background activity on Windows that can consume substantial computing resources without the user being aware of what is happening. The category includes specific services that run on schedule, specific services that respond to specific triggers, and specific services that run continuously in the background. Some of these services are clearly necessary for the operating system to function. Others are optional or are specifically tied to features that the user may not be using or serve purposes that the user may not value. On a typical Windows 11 installation, the cumulative CPU usage from specific background services can reach surprising levels, particularly during specific periods when multiple services are running simultaneously. For users who notice their computer being unexpectedly slow, or whose laptop battery drains faster than expected, or who simply want to understand what their computer is doing, examining the background services is informative. I want to walk you through the specific services that most commonly consume significant resources, how to identify which services are running on your specific system, which services are essential versus optional, and what you can do to control the resource consumption. Let me start with the specific services that are commonly responsible for significant resource consumption. The first is Windows Search Indexer. This service indexes the content of files on your computer so that Windows Search can find specific content quickly. The indexing itself is valuable, but the specific implementation can consume significant CPU during indexing operations. On a computer with many files, particularly documents with substantial content, the initial indexing can take hours and can consume 30% or more of CPU while it is running. Ongoing indexing, when files change, continues to consume resources in smaller amounts. And the second is Windows Update, which includes both the user visible update installation and various background services that prepare and verify updates. The specific CPU usage during active update operations can be very high, up to 70% or more on some systems. The specific verification steps that Windows performs during and after updates contribute additional CPU usage. The third is Windows Defender, which includes real-time protection and scheduled scans. Real-time protection continuously monitors file activity and program execution, which consumes CPU in proportion to the activity. Scheduled scans, which happen periodically, consume substantial CPU for the duration of the scan. The specific scan patterns include quick scans that consume less resources and full scans that consume more. The fourth is Sysmain, which was previously known as Superfetch. This service preloads frequently used applications into memory to make their launch faster. The service consumes both memory and CPU as it analyzes usage patterns and moves data into memory. On some systems, Sysmain has been identified as consuming excessive resources, particularly on systems with mechanical hard drives, where the service's behavior patterns conflict with the drive's strengths. The fifth is telemetry and diagnostic services, which include several specific services that collect and send diagnostic data to Microsoft. The collection process consumes CPU, and the transmission consumes network bandwidth. The specific resource consumption is usually modest, but continuous. The sixth is delivery optimization, which is a service that handles the distribution of Windows Update content. The service can both download updates from Microsoft and peer-to-peer share updates with other computers on the same network or on the internet. The specific resource consumption depends on what the service is doing at any given time. The seventh is printer services, which include the print spooler and related services. On systems with network printers, these services can consume resources when managing print queues, discovering printers, and processing print jobs. The eighth is various background services that are tied to specific Windows features. Features including Cortana, widgets, notifications, and various other user-facing elements have supporting services that consume resources even when the features are not actively being used. The ninth is Windows Modules Installer, which handles the installation and configuration of Windows components and updates. The service can consume significant CPU during periods when it is processing updates or reconfiguring the system. The 10th is various services related to specific installed software. Applications that install themselves as services, including antivirus products from third parties, cloud storage clients, communication tools, and various other categories, contribute to the overall background service load. The specific services vary by installation. To identify what is running on your specific system, Windows provides several tools. The first tool is Task Manager, which can be opened with Ctrl-Shift-ESC. Task Manager shows current CPU usage by process, including services. The Performance tab shows overall system resource usage. The Services tab shows the status of Windows services. The Startup tab shows applications that are configured to start with Windows. Together, these tabs provide a reasonable overview of what is running. The second tool is Resource Monitor, which can be opened from Task Manager's Performance tab. Resource Monitor provides more detailed information about what processes are using what resources, including specific file and network activity. The third tool is Services, which can be opened by running services.msc. This tool shows all Windows services, their current status, their startup configuration, and allows specific services to be stopped or reconfigured. The fourth tool is Process Monitor, which is a free tool from Microsoft's sysinternal suite. Process Monitor shows detailed file system, registry, and process activity in real time, which is useful for identifying the specific operations that services are performing. The fifth tool is Performance Monitor, which provides detailed statistics about system performance that can be used to identify patterns in resource consumption over time. Now let me describe which services are essential versus optional. Essential services include those that Windows absolutely requires to function. These include the core system services, the network services, the user interface services, and the security services. Disabling essential services can cause Windows to fail to boot or to function incorrectly. Optional services include those that provide specific features that not all users need. These include services for specific hardware that is not installed, services for specific Windows features that the user does not use, and services for specific integrations with external systems that the user does not use. The specific determination of which services are essential and which are optional depends on the specific configuration of the computer and on the specific features the user uses. A service that is essential for one user may be optional for another. The specific safe approach is to understand each service before disabling it, and to disable only services whose purpose is clear and whose absence will not affect the user's experience. Let me describe what you can do to control resource consumption. The first action is to identify the services that are consuming the most resources on your specific system. Use Task Manager and Resource Monitor to see what is running and what it is using. This provides the information needed to decide what to address. The second action is to adjust the specific settings that control the most resource-intensive services. Windows Search can be configured to index fewer locations, which reduces the indexing load. Windows Update can be configured to be less aggressive about downloads and installations. Windows Defender can be configured with specific exclusions for directories that do not need to be scanned continuously. These adjustments can substantially reduce the resource consumption of these specific services. The third action is to disable specific services that you do not need. The Services.msc tool allows you to set services to not start automatically. The specific services that can be safely disabled depend on your configuration, but common candidates include services for features you do not use, services for hardware that is not present, and services that connect to services you do not use. The fourth action is to manage the specific startup applications that are configured to start with Windows. The Startup tab in Task Manager shows these, and many of them can be disabled without affecting functionality. Disabling unnecessary startup applications reduces the continuous resource consumption of applications that launch when Windows starts. The fifth action, for users who are willing to invest more effort, is to use specific debloating tools that are available from the Windows enthusiast community. These tools automate the process of disabling unnecessary services and features. The specific trade-off is that some tools can be too aggressive and can cause problems. Using these tools requires care and understanding. The sixth action, for users whose computers are persistently slow despite these adjustments, is to consider whether Windows is the right operating system for their computer and needs. Linux, which I have discussed in other contexts, has substantially lower baseline resource consumption than Windows. For computers that struggle with Windows, Linux can provide a significant improvement. The broader observation about Windows background services is that the operating system has accumulated substantial background activity over the years. Each new Windows version adds services, and older services are rarely removed. The specific accumulation produces a system where the operating system itself consumes substantial resources, leaving less for the applications that the user actually wants to run. The specific trend is toward more background activity rather than less, for users who prioritize performance and efficiency. The specific response is to actively manage the background activity. For users who do not want to invest in this management, accepting the baseline behavior is a reasonable choice, though the trade-off is that the computer will perform less well than it could. Subscribe for the next video, which provides a specific walkthrough of identifying and controlling the highest resource background services on Windows 11 with the specific tools and the specific adjustments to apply. And, in the comments, tell me which specific services have been most problematic on your system and what you have done about them. The specific experiences of many users are what build the collective understanding of how to manage Windows performance effectively.